Hey, this is Manav Misra, aka Codefinity. Got a question from a student regarding something called the bubbleSort algorithm. Let me start by saying this is definitely just an algorithm problem. This really isn't practical application. But our challenge here is simply to take an array, for example, an array of numbers, and to sort it from highest to lowest. But we're not allowed to use any of the array methods. No pushing or popping or shifting or any of that stuff. And of course, we can't use the built-in sort method on the array prototype. So before I get into this very imperative code, let me just kind of start with a little visualization. And I'll say that what's the benefit of really doing this? I don't know. I'm hard to say that there is much benefit aside from just sort of learning programming. And there's a chance that somebody may ask about an algorithm problem like this in an interview. But let's look at a couple of cards here. So let's just pretend there's two things in this array. And we have, this is index 0, this is index 1. So these are out of order. I would like to get them like this. What is the algorithm for doing that? Well, here in index 0, I need to hold on to this value. So what I'm going to do is just kind of put it off to the side. I'm going to remember, oh, that's the number 2. Okay, so put that off to the side. So this is how it's going to work in the array, is why I'm doing this. So keep track of this value. Now take the higher value and move it into the index 0, and then go back and grab that number 2 and put it over here at index 1. So that is sort of the visualization of how we're going to be performing this sort. Let's take a look at the actual code. So I've done this in a very deliberate way where I'm literally going index by index, okay? And then when we finish with this, we're going to see the sort of the official bubbleSort algorithm solution, and we'll compare and contrast a little bit. So we're going to start with this array, index 0 and index 1. So that's going to be 52 and 69. We're not worried about any other elements, just those two elements. If index 0 is less than index 1, it certainly is, then we need to do something. Just like we talked about in the cards. Take index 0's value and just store it somewhere. For example, just call it side value. That's the number 52. Next, take index 1's value and replace index 0 with that value, which is 69. So at that point, we have 69 in both indexes. But remember, we still have 52 over to the side. We just need to bring that back. And that's what we do in the next iteration. That side value, go ahead and put that in to index 1. And that's it. These have now officially been swapped. We need to keep going down the line here. The next two elements are index 1 and index 2, 52 and 15. Nothing to do here because they're already in order. Let's keep going. Next, we have index 2 and 3. It's 15 and 64. These are out of order. So the same logic applies. Take index 2's value, keep it to the side. Take index 3's value and replace index 2 with that value. And remember, at this point, they both are the same. And then we need to bring back the 15 and pop that back into index 3. And that's what we see here. Continuing down the line, the next two are also out of order, but I won't repeat the process because it's exactly the same. Let's take a look at the result of our work here. Let's just say console.log nums, see how far that got us. So going back here, I've already was playing with it earlier, but this is where we are right now. It kind of worked. We got rid of the 69 and 52 and some of this, but you can see these are still out of order. So clearly we can't just go through it one time. We have to keep going over the whole array. Okay, so let's think about how that might look. I'm still going to keep it with the numbered indexes, but I did create a do while in order to help us get closer to our goal. So this is what the code looks like with the do while. All right, so I've created an outside variable here, and just to refresh yourself, a do while means the stuff in the braces of the do is guaranteed to go one time, and then the while loop just checks a condition and sends it back up to the top until that condition is met. So out of order, we're going to assume that things are out of order. I'm just going to set it to true. Could have just left it as null. I set it to true. So here I'm just logging the numbers up front so we can see the progression. And the logic in here is largely the same. It's only that I've added else's on here. So we're just going to, if this is else, so we're just doing this like one set at a time instead of checking all the way through. So we've got if, else, if, else, if. And the reason why I'm doing that is just to make it a little bit more clear that if none of those conditions hit, in other words, we've checked all of the elements, 0, 1, 2, 3, and 4, they're already in order. We didn't have to do any sorting. Then that means that the else is going to be taking place, and that sets our out of order to false, which allows us to exit out of the loop. And that's why I set it up this way. So this is still, just manually checking each index number by number, but now we're doing it in a loop. And when we take a look at the result here, we can actually see the progression. So we started here, and then we got a little bit of sorting, and it went all the way down the line, and we actually were able to sort this out. So our algorithm here works just fine. Of course, if we had 100 elements or a bunch of elements, we're not going to sit there and do this manually. So it stands to reason that there would be a for loop to go over the entire array, and that's actually what we see in the official bubbleSort algorithm that was provided to me. So this bubbleSort algorithm takes an array, and here's the code here. We see this for loop. A lot of this is the same as what we saw, but here's the for loop. That just makes sure that we cover the entire array and keep repeating the process. So there's the swapped. We called ours out of order. And so this kind of goes the other way. We were checking, hey, is it out of order? And they are checking, hey, have we swapped this yet? So it's sort of the other way, but the same type of logic. So we're running a for loop to make sure we go over the entire array. They are also doing some additional checking here. They are saying, hey, I want to make sure that the current element and the next element both are truthy. I don't want to spend time. So they're checking to see if those are indeed truthy, and they're also checking to make sure that the current element is less than the next element, which is exactly what we were doing in our version. So they just have a little more checking here. Otherwise, the logic here is the same. In fact, for the last part of this, I've already added some comments here. So kind of filling this in with comments, we keep running this thing across all the entire array. We just talked about this. If the current element and the next element are both truthy, and if the current element is less than the next element. That's what's happening here. Put the current value off to the side. They called it temp. We called it side value. Replace the current element with the value from the next element. So at this point, like we saw in our previous visualization, both the current and the next element are the same. So what we need to do to fix that is take that next element and go back and grab that temporary value we're kind of holding on to. And once we've completed all of this, all the way down, we're going to say swapped is true. Okay, and then here we have a while loop, and that's going to keep running. At some point, it's going to exit when swapped is true after the entire array has been checked. So I hope this visualization did help. Like I tried to show one without the for loop and just manually checking the indexes, or indices as some people say. And then here we do it with an actual for loop in the official solution. And besides just kind of learning the inner details of programming and maybe possibly preparing for an algorithm problem or interview, realistically we're going to do what? Array, prototype, sort, and move on with our lives.